Get ready to explore some incredible discoveries from the James Webb Space Telescope. Like, it's really giving us this whole new view of the universe. Like, when you put on a new pair of glasses and you're like, whoa, I've
Yeah.
never seen things like this before.
Yeah, it's true. James Webb is the most powerful telescope that humans have ever launched into space. And even though it's only been up there for a short time, it's already making groundbreaking discoveries.
Okay, so it's really powerful. But what makes it so special? Like, it's not the first telescope we sent up there, right?
Well, the JWST is special because it sees the universe in a whole different light. Literally. It's designed to detect infrared light, and infrared light is invisible to our eyes.
Infrared. Isn't that what they use in those night vision goggles?
Yeah, exactly. And just like night vision goggles help us see in the dark, infrared light helps the JWST see through clouds of dust and gas that normally block our view of distant objects.
Oh, so it's like those clouds are parting like curtains, and JWST is giving us like a front row seat to the universe's greatest show?
That's a great way to put it. And some of the most interesting stuff in the universe, like the very first stars and galaxies, are shrouded in these clouds of dust and gas.
So we just couldn't see them before this?
Not really. Our previous telescopes, even Hubble, which was amazing, couldn't really pierce through those clouds the way that JWST can.
Wow. That's got to be like finding a hidden treasure chest no one even knew existed.
Yeah.
So what kinds of things are we finding in this treasure chest?
Well, one of the things that has every scientist really excited is that JWST is able to study the atmospheres of planets outside of our solar system, what we call exoplanets.
Exoplanets. Okay, I've heard that word before. Those are planets that orbit other stars, right? But how can we even tell what the air is like on a planet that's light years away?
It's all about the light. When a planet passes in front of its star, some of the starlight filters through the planet's atmosphere, if it has one. The JWST can analyze that filtered light, kind of like we're looking for fingerprints.
Fingerprints? What do you mean?
Different molecules in the atmosphere absorb specific wavelengths of light, leaving a unique signature on the light that passes through. It's like each molecule has its own barcode.
So by analyzing that light, we can tell what the atmosphere is made of.
Yeah, and that's how we found some really amazing things on a gas giant called WASP 39b.
WASP P39b. Okay, I'm ready. What's so special about this WASP planet?
Well, for starters, it's huge, even bigger and puffier than Jupiter. But what really surprised everyone was that the JWST detected sulfur dioxide in its atmosphere.
Sulfur dioxide? Like volcanoes?
Well, it is produced by volcanoes here on Earth, but here's why that's a big deal. On Earth, sulfur dioxide is really important for forming the ozone layer.
Wait, the ozone layer? The one that protects us from the sun?
That's the one. Now, finding sulfur dioxide on WASP 39b doesn't necessarily mean it has life, but it does suggest that there might be an ozone layer there, which could make it surprisingly similar to Earth in some ways.
That's mind-blowing. It's like this planet is giving us a sneak peek into what makes a planet habitable, even though it's light years away.
Exactly. And the most exciting part is we're only just starting to see what JWST can tell us about these exoplanets. There are thousands more out there waiting to be explored.
This is incredible. But before we get lost in the vastness of exoplanets, I heard there are some pretty intriguing possibilities for finding life a little closer to home.
You heard right. Exoplanets are fascinating. But we can't forget about the potential for life in our own cosmic backyard, our solar system. And there are a few places that have scientists particularly intrigued.
Okay, do tell. Are we talking alien life in our own solar system? Where do I book my spaceship tickets to?
Hold your horses. We're talking about...
This is like something straight out of a science fiction movie. Are we talking about sending probes to explore these hidden oceans?
There are missions in development right now. And one of these moons is giving us a peek at what might lie beneath its icy shell in a really dramatic way.
Okay, you have to tell me. Which moon is putting on a show?
Picture this. Enceladus, this tiny moon spewing gigantic plumes of water vapor into space from massive cracks in its icy surface. These plumes are like 40 times the size of the moon itself.
Whoa. That's one powerful geyser. What's causing that?
It's not just a geyser. It's more like the moon is letting out a giant sigh, revealing a glimpse of the ocean hidden beneath.
Okay, that image is both beautiful and kind of terrifying. But if these plumes are coming from a hidden ocean, could that mean
that there's life down there? It's a possibility. And the JWST, with its powerful infrared vision, might be able to detect signs of life, or at least the building blocks of life within those plumes.
This is blowing my mind. It's like we have a chance to find alien life right here in our own neighborhood. But we're not done yet, are we? You mentioned something about the early universe.
That's right. Get ready to journey back in time to the universe's dark ages.
The Dark Ages. That sounds ominous. What happened back then? Was the universe just an empty void?
Not quite empty, but pretty close. The dark ages were a period hundreds of millions of years after the Big Bang, before stars even began to form.
Wait, so how can we even see anything from that long ago? Wouldn't the light from back then be long gone?
That's where things get really interesting. You see, the universe is constantly expanding, and as light travels through this expanding space, its wavelength gets stretched out.
Stretched out, like a rubber band.
Exactly. The farther the light travels, the more it gets stretched, shifting toward the red end of the spectrum, a phenomenon called redshift. And the light from the early universe has been traveling for billions of years.
So what you're saying is the light from the early universe might have started out as visible light, but it's been stretched so much that it's now infrared light?
Precisely. And guess what's perfectly designed to see infrared light?
The JWST. It's like we built a time machine without even realizing it.
That's one way to think about it. And one of the most exciting things we're seeing in those early chapters of the universe is galaxies. Lots of them.
Galaxies, like the massive collections of stars that make up the universe.
The very same. But here's the kicker. Some of these early galaxies are already more massive and mature than our models predicted. It's like finding a fully grown oak tree where you only expected a tiny sapling.
So what does that mean? Did we get something wrong about how galaxies form?
That's the million-dollar question. It's forcing us to rethink some of our fundamental understanding of the early universe. Maybe stars formed faster or earlier than we thought, or maybe there were other processes at play that we haven't even considered.
It's like the universe is full of surprises and the JWST is revealing them one by one.
That's the beauty of science. Every answer leads to more questions.
And speaking of big questions, there's another cosmic heavyweight that the JWST is giving us a closer look at. Supermassive black holes. Black holes, those are always fascinating. But we already knew about those, right?
We did, but the JWST is allowing us to study them in a way we never could before. You see, supermassive black holes lurk at the centers of most galaxies, but they're often hidden behind thick clouds of gas and dust.
So how can we see them?
That's where the JWST's infrared vision comes in handy again. Infrared light can penetrate those clouds, giving us a much clearer view of what's happening around these mysterious objects.
So it's like the JWST has X-ray vision for black holes.
You could say that. And what we're seeing is already changing our understanding of how these cosmic giants influence the galaxies around them. For example, the JWST recently captured this amazing image of two galaxies merging. And guess what was right in the middle of this cosmic dance?
Don't tell me a supermassive black hole.
You got it. And not just any black hole. This one was actively devouring material from its surroundings.
Whoa.
A feeding frenzy of cosmic proportions.
Whoa. That's both terrifying and amazing. But why is this observation such a big deal?
It gives us clues about the relationship between supermassive black holes and the evolution of galaxies. There's this chicken or the egg question in astrophysics. Which came first, the galaxy or the black hole?
That's a good question. It's like trying to figure out if the seed came before the tree.
Exactly. And while we don't have all the answers yet, the JWST is giving us the tools to study these interactions in detail, which will hopefully lead us to some groundbreaking discoveries.
This is incredible. It feels like we're on the verge of rewriting astronomy textbooks, thanks to this incredible telescope.
And we're just getting started.
You know, it's mind-blowing to think about all these discoveries with the JWST, but how do we even know we're getting it right? We're talking about objects that are billions of light years away.
That's a really good point. The accuracy of this telescope's data is so important to everything we're discussing. It all comes down to this really meticulous process called calibration.
Calibration. Is that like making sure your camera is in focus before you take a picture?
It's similar, but on like a much larger scale. Imagine you have this brand new high-tech telescope, but each of its instruments has its own little quirks. Think of it like having a team of brilliant musicians, each with a unique instrument, but they've never played together before.
Okay, I'm following you. What does that have to do with calibration?
Well, just like you'd need to tune those instruments so they're all in harmony. We need to calibrate the JWST's detectors, which are designed to capture different wavelengths of light, so they're all on the same page.
So it's like making sure everyone's reading from the same sheet music?
Precisely. We need to make sure that the data we're getting from each detector is accurate and consistent. And we can do that by observing objects with well-known brightnesses, like stars that have been well studied.
So it's like having a cosmic tuning fork.
Exactly. By comparing what the JWST sees when it looks at these standard stars with what we already know about them, Scientists can fine-tune each detector so we can be sure that the data is as precise as possible.
Okay, that's reassuring. It's like having a team of cosmic fact-checkers making sure everything adds up.
Exactly. Speaking of fact-checking, one of the most exciting frontiers in exoplanet research is the search for atmospheres around rocky Earth-sized planets. We've talked about WSP-39b, which is a gas giant, but finding an atmosphere around a much smaller rocky planet, now that would be a game changer.
Okay, so finding Earth's twin is a pretty big deal. Why is that so important?
Well, think about it. A rocky planet roughly the size of Earth with an atmosphere, that's about as close as we can get to potentially finding another planet that could support life as we know it.
That makes sense. It's like finding a planet that's not just in the habitable zone, but actually has the potential for oceans, clouds, maybe even breathable air.
You got it. And while we haven't found definitive proof of such a planet yet, there have been some pretty tantalizing leads. One study focused on a planet called GJ486b, which is about 30% larger than Earth and orbits a red dwarf star.
A red dwarf star. Aren't those smaller and cooler than our sun?
They are, and because they're dimmer, it makes it easier to study the planets that orbit them. Imagine trying to spot a firefly next to a spotlight. It's a lot easier to see the firefly if the spotlight is dimmer.
Okay, that makes sense. So what did they find out about GJ486b? Does it have an atmosphere?
Well, that's the million-dollar question. Here's what we know. The team used the JWST to observe what we call a transit, which is when the planet passes in front of its star from our point of view.
Right, it's like a mini eclipse, and that's how we even knew the planet was there in the first place.
Exactly. But here's the cool part. As the planet transits, some of the starlight passes through its atmosphere, if it has one. And by analyzing that light, we can look for the fingerprints of different molecules, just like we talked about with WSP-39b.
So it's like we're trying to sniff out the air on this distant planet by looking at how the light changes as it passes through it.
You got it. And one of the researchers studying GJ486b found a signal that could indicate the presence of water vapor in its atmosphere.
Water vapor. That's huge. Does that mean there could be, like, actual liquid water on this planet?
Not so fast. Here's where it gets even more interesting. Another researcher, using a different method to analyze the same data, didn't find that same signal.
Wait, what? So it's a cosmic mystery. Does GJ486b have an atmosphere with water vapor or not?
That's the big question. And it really highlights how science is a process of constantly refining our understanding. We need more data, more observations, and more analysis before we can say for sure.
So the jury's still out on GJ486b. But the fact that we can even look for these subtle clues on a planet that's so far away is incredible.
It really speaks to the power of the JWST, and it's a great example of how scientists are constantly pushing the boundaries of what we thought was possible.
Speaking of pushing boundaries, remember those ocean worlds we talked about? Europa and Enceladus, with their hidden oceans beneath the ice. Has the JWST been able to take a peek at those?
It has. In fact, the JWST captured this incredible image of Enceladus's water vapor plume. And it was even bigger than we imagined. We're talking like 40 times the size of the moon itself.
40 times the size of the moon. That's like a giant fountain erupting into space.
It's really something. But remember, those plumes aren't just a pretty show. They're a treasure trove of information about what might be hidden beneath Enceladus's icy shell.
You mean we can analyze what those plumes are made of, just like we're trying to do with exoplanet atmospheres?
Exactly. Scientists are already hard at work analyzing the light passing through those plumes. They're looking for the chemical signatures of life.
So it's like those plumes are giving us a direct line to sample the ocean on Enceladus without ever having to drill through the ice.
That's one way to think about it.
What about Europa? Any juicy tidbits from there?
You bet. While we haven't seen any of these dramatic plumes erupting from Europa, the JWST observations have shown that the surface is much more dynamic and diverse than we ever imagined.
Dynamic and diverse. Give me the details.
We're talking about intricate details in the ice, strange formations that hint at geological activity, and potential clues about what the composition of its subsurface ocean might be. It's like the JWST is peeling back the layers of a cosmic onion. We're seeing more and more complexity with every observation.
It's like every time we look at these moons with the JWST, we just discover even more mysteries. But we're not talking about finding alien fish fossils or anything, are we?
Not just yet. But analyzing this data takes time. Scientists are meticulously piecing together the puzzle, looking for patterns and anomalies that could point to something truly groundbreaking.
So it's a waiting game. But the anticipation is killing me. It's like we're on the verge of answering one of humanity's biggest questions. Are we alone in the universe?
And that's what makes this era of astronomy so captivating. With each new observation, each new piece of data, we're getting closer to unraveling the universe's greatest secrets.
This has been an incredible journey. We've covered so much ground, from calibrating a telescope a million miles away to the mind-boggling possibility of finding life in our own solar system.
And we're not done yet. There's one more fascinating aspect of the JWST we need to explore. Its ability to capture the spectra of these distant galaxies, these cosmic barcodes that unlock the secrets of the universe's building blocks.
Okay, you've officially piqued my curiosity. Tell me more about these cosmic barcodes and what they're revealing about the universe.
Well, imagine you have a prism and you shine a beam of white light through it.
It splits the light into all the colors of the rainbow, right?
Exactly. And just like that prism splits white light into its individual colors, the JWST can split the light from distant galaxies into its individual wavelengths, creating a spectrum.
Okay, I'm picturing a cosmic rainbow made from the light of a galaxy billions of years ago. But what can we actually learn from that?
That's the beauty of it. That rainbow or spectrum is like a fingerprint. It's unique to the object that's emitting the light. Each element in the universe absorbs and emits light at specific wavelengths, creating this distinct pattern of bright and dark lines within the spectrum. We call these patterns spectral line.
So it's like each element has its own cosmic signature tune that the JWST can hear.
That's a great way to put it. By analyzing these spectral lines, we can determine the chemical composition of stars, galaxies, even the early universe.
So we can tell what a galaxy billions of light years away is made of just by looking at its light. That's incredible.
It is. And not only can we identify what elements are present, but we can learn about their temperature, their density, even their motion towards or away from us. It's like having a cosmic speed camera.
Wow. So these spectra are giving us a glimpse into the chemical makeup of the universe as it was billions of years ago.
Exactly. And what we're finding is both fascinating and challenging our current understanding of how the universe evolved.
Okay, I have to know. What kind of surprises are we uncovering?
Well, one of the most surprising discoveries is that even some of the earliest galaxies observed by JWST show evidence of heavier elements like carbon, oxygen, even iron.
Heavier elements. But wait, I thought those weren't formed in the Big Bang. Didn't it take stars to create those?
You're exactly right. Heavier elements are formed in the nuclear furnaces of stars, and then they're scattered throughout space when those stars explode as supernovae.
So finding these heavier elements in very early galaxies means what exactly?
It means that stars must have formed, lived, and died much earlier than we previously thought. It challenges our current timelines for star formation and galactic evolution.
So it's like finding a fossil of a complex organism in a layer of rock where it shouldn't exist. It's throwing a wrench into our understanding of the early universe.
Precisely. And that's what makes this era of astronomy so exhilarating. The JWST is not only confirming what we thought we knew, but also revealing a universe that is far more complex and awe-inspiring than we ever imagined.
This is absolutely incredible. It feels like we've only just scratched the surface of what the JWST will reveal about the universe, but I have a feeling this is just the beginning, right?
You're absolutely right. The JWST is a game changer, and we've only just begun to explore the treasure trove of data it's already gathered. And as we continue to refine our techniques and combine JWST data with observations from other telescopes, who knows what other mind-blowing discoveries await us?
It's amazing how much we've learned from the James Webb Space Telescope, it feels like. I don't know. We're just getting started.
Oh, absolutely. The JWST really is like having this incredible time machine and a superpower microscope all in one. And like you said, we're really just starting to explore the possibilities.
So where do we go from here? What are the big mysteries that the JWST might help us solve, in the coming years?
Well, the search for life beyond Earth is definitely still at the top of the list. With every new exoplanet atmosphere we can analyze, we get closer to answering that huge question, are we alone?
Yeah, it's amazing to think we might actually be able to find evidence of life on other planets in our lifetime. But what about our own cosmic backyard? Are there any plans to further explore those ocean worlds, Enceladus and Europa?
Absolutely. There are missions being developed right now to do just that. I mean, imagine sending a probe to Enceladus with instruments that can sample those erupting plumes and analyze them right there on the spot.
That would be incredible. It's like having a front row seat to an alien ocean right here in our own solar system. What about the early universe? Will the JWST be able to keep looking back in time to try to unlock those secrets from the Big Bang?
For sure. As we continue to refine the instruments on JWST and we develop even better analytical techniques, we're going to be able to see even fainter, more distant objects than we ever have before. Objects that could really hold the key to understanding the universe's biggest secrets, like the nature of dark matter and dark energy.
Dark matter, dark energy, those are still such big mysteries. I mean, what do we even know about them at this point?
That's just it. We don't know much. We know that dark matter makes up a large portion of the universe's mass, but we can't see it, and we can't interact with it directly. It's like trying to understand a book by just feeling the weight of the pages.
Okay, and dark energy. That's the force that's causing the universe to expand at an accelerating rate, right?
Exactly. It's like the universe hit this growth spurt, and we're still trying to figure out why. These are really fundamental questions about like the fabric of the universe. And the JWST, along with other telescopes and missions, might finally give us what we need to figure them out.
This is all so incredible. It's exciting, but it's also kind of humbling, you know, to think we're alive at a time when we can even ask these questions about the universe,
Yeah.
and we actually might find the answers.
I completely agree. It's amazing what we can do when we put our minds together to explore.
Well, I have to say, this deep dive has been a wild ride.
Mm.
From exoplanets to ocean worlds, from the early universe to the mysteries of dark matter and dark energy. The JWST is really changing how we understand the cosmos.
It really is, and I can't wait to see what we discover next.
That's the most exciting part. The universe is full of surprises. And with the James Webb Space Telescope as our guide, we're definitely in for a treat.
Until next time, keep looking up and never stop asking those big questions.
This is The Deep Dive signing off.